Hello ladies and gentlemen, got a few things I want to clear up and share with you. Here's one idea. We're going to talk about graphing or not imaginary numbers. And those are numbers that have I in them. Okay, so this is our topic. We're going to talk about whether or not we can graph imaginary numbers. Well, when we're thinking about graphing, most of the time we think about the real number lines being intersecting at 0 and being perpendicular to other. That was invented, by the way. That was invented by a man named René Descartes. And what René Descartes was saying was he was saying that if we deal with the real number system, now let's remember what the real number system is. Real number system is composed of all of the rationals with all of the irrationals. An example of a rational number is 0, 1, -7/2, -5. These are all rational numbers. An example of an irrational number would be a number that can't be put as a fraction, where a over b are integers, so it would be something like √2 or √7 or pi. Those are irrational numbers. So when we put all of these together, we get what we call the real number system. And we represent a real number system on a real number line. Kind of interesting. So there's your real number line. And this will have all of these numbers. So we'll have a place for 0, we'll have a place for 1, we'll have a place for 2 and 3. We'll have a place for -1, -2, and -3. We'll have a place for √2. √2 would be somewhere in here. We'll have a place for pi. Pi would be somewhere in here. We'll have a place for √7. We'll have a place for -5. It's going to be down here somewhere. Okay, so all in -7/2, so that's -3.5, so somewhere in here. Okay, so there's your real number line, and it composed of all the real numbers. And René Descartes decided to take another real number line and put it like this. He called this one the x-axis. He called this one the y-axis. And this, too, was representative of all the real numbers. Oh. And again, this, too, had all representations of it. So √2 is here, too. Here it is here. Oh, no, √2 won't be that far. √2 is definitely not here. That was a mistake. √2 is down here. It's about 1.4 something, I think. Sorry. So √2 is somewhere in here. Pi is going to be up here, 3.14 somewhere. -7/2 would be -3.5, so it's going to be down here somewhere. Okay, so now what you've got is you've got the real number line going this way, real number line going this way, and we decided that we'd make coordinate pairs. And the coordinate pairs would be composed of x, y at a point. And that point, this x value, would definitely come from this real number line, so it's going to be a real number. It's an element of the reals is the way we say that. And this y is definitely an element of the real numbers, and meaning that this needs to be a real number and this needs to be a real number. So this entire plane, okay, in 2 dimensions, going this way and this way, has real numbers everywhere on it, okay, and nothing but real numbers can go on here. So that's the concept of graphing on a coordinate Cartesian plane. And René Descartes, his plane he made up is called the Cartesian plane, and by definition it's made up of a real number line here and a real number line here. That by definition, there's no talking about that. So that lends us to a problem. Where are we going to put I? Well, I is not a member of the real number system, so I can't go on here. Basically, I has no place on here. You're not allowed to put it anywhere on there. This has nowhere for I. So if you get a number that has I in it, like 3i, there's nowhere to put it. Bottom line, when René Descartes made this system, it wasn't made to handle i's. It was only made to handle real numbers. So something else would have to be developed later on to be able to graph i's. And we do have different things. And here's an example of maybe how someone might want to set up a graphing system for complex numbers. I've seen this used. It can be helpful. What they do is they put the real number part of the complex number down here. They put the bi part up there. So if you have a complex number like 3 plus 5i, what you can do is you can come across here to 1, 2, 3. You come up here to 1, 2, 3, 4, 5. So you go over 3 in the real number part, you'd go up to 5 in the I part, and that point there would represent that number. So here's your 3, and here's your I, and this is your A value, and this is your B value, because remember, complex numbers are in this form, and that was something that we talked about earlier. Where would you put a number that looked like, I don't know, I3? So that's a different number that I'm going to try to place. Well, you'll notice that the A is 0, and it's going to be root 3. So root 3 is approximately, root 3 is larger than 1. It's less than 2, so it's somewhere in here. So somewhere in here you would, oh, sorry, the A part 0, so the A part 0. Root 3 is larger than 1 but less than 2, so it's going to be somewhere in here. So that number there would be 0 plus I root 3, and this part down here would be 0 minus I root 3, because the B part is the root 3, and we're setting it up on there. So this part would be root 3, and this part would be negative root 3. Okay, so bottom line, if we're graphing on a Cartesian plane, which is what this is, then there is no place to put imaginary numbers. They cannot be graphed on a real number line or on a real plane. That's it. That's all that exists. We'll talk more in a minute.